Welcome back, student. Now today we'll discuss on uh, Dalton's law of partial pressure. Okay, so this is the continuation class of psychometric chapter in your RSC subject. Now in the previous lecture video already discussed on the defined introduction of psychometric process and introduction of psychometric chapter, and there are some psychometric terms which are related like dry air, moisture air, and dry bulb temperature, wet bulb temperatures, specific humidity or relative humidity. So all these terms already we have discussed in the previous lecture video. Now today we'll discuss on Dalton's law of partial pressure, and there are some psychometric relations like specific humidity in case of or humidity ratio, relative humidity, degree of saturation. So all this all this topic will be covered up in this lecture video. Now as you see that Dalton's law of partial pressures, what is that? Now the total, this Dalton says that, actually the law says that the total pressure exerted by the mixture of air and water vapor is equal to the sum of the pressure which deals or which constituent would exert if it occupied the same space by itself. Okay, so suppose in a sample volume of water vapor and a dry air mixtures, so the total barometric pressure given by the particular that space or a sample is to be summation of the partial pressure of dry air plus partial pressure of water vapor, because all of you know actually that basically that air or moisture air basically consists of dry air and there are some amount of water vapor also present. It is not possible that almost all the vapor should eliminate from the dry air, moist air. So there are some content are there. So obviously if there are some mass of partial, there are some mass of dry air present, some mass of water vapor present, so obviously there are also some partial pressure will be given by the dry air as well as water vapor. So the total pressure exerted by the mixture of air and water vapor is equal to the sum of the pressure which constituent would exert if it occupied the same space by itself. Okay, so this is the Dalton's law of partial pressure. Now go to the next topic. Next topic is that psychometric relations. In psychometric relation, first is specific humidity or humidity ratio, or sometimes it's also called moisture content present in the particular mixture. Now specific humidity or humidity ratio or moisture content basically is into a W, small w. Now that is equal to ratio, basically it is ratio, or it can be defined as the ratio between mass of water vapor divided by mass of dry air. So it is the ratio between two, mass of water vapor divided by mass of dry air. Okay, now as you know that PA, VA, TA and MARA, so basically this indicates, so PVTB means pressure, volume, temperature as well as mass, and this is the basically gas constant, and that is, and this A suffix basically denote the constant, and basically it is used for indicate the dry air. Okay, so this all these things, pressure, volume, temperature, mass and gas constant is indicate for dry air, and similarly like PV, VV, TV, MV, RV is similarly pressure, volume, temperature, mass and gas constant for vapor. Okay, water vapor. So I think you will all do aware of that. Now obviously as it is that it follows the gas equations as it is dry air or air, and we assume that is basically ideal gas, so obviously it follows the ideal gas equation, you know that. So PV is equal to MRT, it will be followed by the mixture, right? So you can write in terms of PAVA is equal to MRT in terms of dry air for conditions, and for water vapor you can write these equations. Now PAVA is equal to MA RA TA and PVBP is equal to MB RB TV. Now in the definitions of specific humidity, so mass of water vapor present in a particular in dry air at a specific volume, at a particular volume region, uh, and due to the mass of dry air, so mass of dry air present at a particular region, at a particular specific volume region. So if the volume is same for in case of VA, so that will be V is equal to VV. Similarly, it will be TA is equal to TV is equal to TD, because the temperature for the same temperature, for the same dry valve temperature, for the same volume, amount of, so mass of water vapor present divided by mass of dry air present, that's the ratio that indicates the specific humidity. So if VA is equal to VV and T is equal to TV is equal to TD, so that means all this term will be same. So after all, you can get from these equations PV by PA that equal to MB by MA into RB by RA, because TA and TV both are same, so that will be cancelled. So after that, so V and VV both are same, so after all the equation becomes PA is equal to MARA and PV is equal to MBRB. So if you write that PV by PA, that you can write that MVRV divided by MARA from these equations. Okay. Now as you know that humidity ratio is the ratio of mass of water vapor present at a particular volume region, on a specified region at the same temperature, and divided by mass of dry air present at a particular same volume in a particular same temperature. So that will be, so W, so humidity ratio is equal to MV by MA, that equal to, so MV by MA is equal to, you can write, so PV into RA, okay, PV into RA divided by PE into RV. So in terms of MV by MA, you can write PV RA divided by PA RV. Now in this equation, so RA is equal to 0.287 kilojoule per kg Kelvin for dry air. As you know, this is a gas constant value for as dry air, you know that. And for vapor, for water vapor, the value of R is 0.461 kilojoule per kg Kelvin for water vapor. Now if you put these values in terms of RA, RV, okay, so that will be specific humidity is, it will be is equal to 0.622 PV by PA. Now from the Dalton's partial pressure, Dalton's law of partial pressure, it shows that basically PB is equal to, you know that PB is equal to that PA, that is basically dry air pressure, partial pressure, and partial pressure of water vapor. So PB is equal to PA plus PB. So P is equal to PB minus PV. So PA in terms of, you can write that P is equal to PB minus PV. So as you know that PV is basically barometric pressure, which is basically constant. So in this equation, so W is equal to 0.622 PV by PB minus PV. So this is the barometric pressure that given reading, and PV is the water vapor present. Now if you goes up and down corresponding your height or defines alter, so you can see that that PB is constant all these conditions, but PV is change time to time. So in these equations, so basically it's a function of, so it is constant value, it is also a numerical value. So W is only function of PV, right? So these are relations between with partial pressure or partial vapor pressure with specific humidity, okay? And specific humidity or humidity ratio, it's only function of partial vapor pressure, okay? This indicates shows that this expression actually, okay? Now next topic is degree of saturations. In this topic, degree of saturation, we want to learn that what is degree of saturation. Now degree of saturation basically defined the ratio, it's basically defined the ratio of actual mass of water vapor in a unit mass of dry air. So in a unit mass of dry air, what amount of water vapor actual mass present to the mass of water vapor present in the same mass of the dry air when it is saturated. We know that air basically it can be saturated air, it can be unsaturated air. Now saturated air is something is called when the air is supposed to be maximum amount of water vapor that can it absorb, it already absorb, so that can it goes to level that is basically saturated state. Now, so basically in dry air, in a unit mass of dry air, what amount of actual mass of water vapor are present to the mass of water vapor present in the same mass of dry air when it is saturated. So basically it's a ratio degree of saturation for the dry air when it is in normal case, when it is basically in unsaturated case, unsaturated conditions or normal case, and when it reach to the saturated state. So what amount of water vapor present at different case. So this is the ratio. So basically it basically defined also it's sometimes degree of saturation also sometimes also called percentage humidity, okay, or percentage humidity. Now as we know that mu, so it is also degree of saturation, it is basically defined sometimes is called mu. Now mu is the basically defined, it also sometimes defined as W by Ws. Now what is W? W, as you know in the previous topic, that W is your specific humidity, right, or humidity ratio, and Ws, what is Ws? That specific humidity when it is reached at saturated state. So the maximum specific humidity is basically also sometimes also called Ws, or specific humidity at saturation state. Okay, now mu also written as, so basically degree of saturation which is defined, that also defined as W by Ws, or specific humidity by specific humidity of saturated air at the same dry bulb temperatures. Okay, now in the previous point, in the previous topic, as you know, the specific humidity W is equal to 0.622 PV by PB minus PV. So PV is a partial water vapor pressure, water means partial pressure of water vapor, and PV is your barometric pressure that is given by the pressure, and PV also you know that. Now this is your TS diagram, corresponding temperature entropy plot, in which you can see that suppose this is a plot where it will show that suppose the some air that is basically indicates A, which is in unsaturated condition, and it is a basically superheated state, and the corresponding partial state is suppose PV. Now a corresponding temperature TD. Now if you add, now at this particular condition, if you want to add some water, so obviously when you add some water, after some time the water vapor will be evaporate, and obviously as this pressure also PV also increase, if you increase the water content or water vapor content, so the PV also increase. So PV is PV when increase at some level, so they can reach up to this PS, that means saturation pressures. When it reach, that is basically that saturated water vapor. So that is basically PS. So when we add maximum amount of water of a particular moisture air, so obviously it unsaturated air, it will reach to the saturated water vapor at a particular pressure, that pressure corresponding basically called PS. So PV is reached to the PS when the water vapor that maximum that can persist a particular moisture air, so that at that particular time PV will be PS. So that W will be Ws, means specific humidity will be specific humidity, maximum specific humidity. That maximum specific humidity is basically it can define as 0.622 into not PV, it will be PS. It will be PS divided by PV minus PS, because PV is change, because W by Ws, W is already you know that, that this expressions where it is comes, but How does WS? Because WS basically specific humidity of saturated air at the same dBT. Now, suppose that air is basically unsaturated condition in superheated condition. Now you want to add some water with that. Now obviously as it is superheated conditions in unsaturated state, so they will reach to the, so they will want to reach the saturated state, and when you add some water, so there are some water just transform into water vapor and they will evaporate. When they will evaporate, so the amount of water also increase. If the water is present of the mass of water vapor is increased, the partial pressure also increase, so PV also increase, so that pressure also reached at a particular limit. Suppose that reaches PS, and that PS give corresponding, that is cut at a particular point, that is basically saturation state or saturated water vapor, that corresponding partial saturated point. Okay, that corresponding temperature is TD. Now obviously PV is reached to the PS when the specific humidity is maximum, right? So PV when reach PS, so that WS is will be, expression will be 0.622 in terms of PV, that will be PS divided by PB minus PV, not PV, that will be PV in terms of PS, because in WS when you define WS, that will be PS. Okay, so that is equal to 0.622, you will be cancel both these terms, so that will be PV into PB minus PS divided by, so PB minus PV, so PV minus PS, it will be, so PV, so PV will be common out, so PV 1, if you divide by PV here, okay, if you divide PV here, so it will be 1 minus PS divided by PV. Similarly it will be 1 minus PV by PB, right? Now next topic is relative humidity. Now, what is relative humidity? Already discussed in the first class of the psychrometric chapter. Now, relative humidity is basically defined the actual mass of water vapor, in a given volume of moisture air divided by mass of water vapor in a given same volume of saturated air at the same temperature and pressure, right? So that is basically relative humidity. Now relative humidity is equal to, you can write in terms of mv by ms, means mass of water vapor in a given volume of moisture air divided by ms indicate mass of water vapor in a given same volume but saturated air. That's why it is S at the same pressure and temperature. Okay, relative humidity basically defined with the term that is basically phi. Now phi, as you know, that mv by ms, and you know that that it can follows the gas equation, so obviously PV, VV, and you know that all this terminology, that pressure, volume, mass, gas constant, temperature corresponding to vapor, that's V suffix basically indicates for water vapor, and for S indicates for saturated air. Okay, and all this term will be same as like water vapor. Now as the definition says that it is basically as same volume, so underline this term, same volume, same temperature, same pressure. So VV is equal to VS because the volume is same for dry air, for in case of moisture air when it is not saturated, and when it is saturated both volume is constant, means same, and TV is equal to TS, means dry bulb temperature also same, and RV is equal to RS, that equal to 0.646, that equal to kilojoule per kg Kelvin, right? Now as you know that, so you can also written as phi is equal to mv by ms. So mv by ms you can also write from this equation, so because both this term will be cancelled, because vv is equal to vs, similarly tv is equal to ts, and rv is equal to rs, that is given that 0.646. okay, because mass of water vapors, both are mass of water vapor, but one is for unsaturated state for moisture air, and one is mass of water vapor but when it reaches to the saturation state. Now for all two cases that gas constant value is same, so RV is equal to RS, that is equal to 0.646, so that will be same. Ultimately equation become PV is equal to MV and PS is equal to MS. Now you know that phi is equal to mv by ms, so in terms of mv by ms you can write that as mv by ms is equal to, from this equation, mv by ms is equal to pv by ps, right? Now phi is equal to pv by ps. Now as you know that in the previous degree of saturation, mu is equal to pv by ps into 1 minus ps by pb into 1 minus pb by pb. You know that. Now as you know that phi means relative humidity, phi is equal to pv by ps. Now pv by ps here, so mu is equal to, in terms of pv by ps, you can write here phi here, so 1 minus ps by pb into 1 minus pv. So from this equation, so pv you can write as phi into ps, right? pv is equal to phi into ps. So in terms of pv, you can write phi into ps divided by pb, right? Now so mu is equal to, sorry, no. So mu is equal to, as you know that mu is equal to phi into that pv will be cancelled, so that will be pv minus ps and pv minus phi into ps. Now if you multiply with the mu term with that, so it will be mu into pv minus mu into phi ps, and phi, if it is multiplied with that, that will be this one, right? Now that mu into pv, that equal to, suppose mu into phi into ps, that will be in this side, that will be equation become this one. Okay, now if you phi, both these terms in phi is present, so phi will be common out here, so phi is equal to pv minus ps in plus mu into ps. Okay, now in these equations, next line, mu into pv is equal to phi in the bracket pv minus of ps. So both these terms, ps is common here, right? ps is common, so ps into 1 minus here plus, it is minus, so that's why minus plus, so that's why it is minus. So 1 minus mu, right? So mu is equal to phi into 1 minus mu into ps, right? Now here it is pv, so if you divide here pv, if you divide here in this side, pv will be cancelled, that's why it's 1. Similarly 1 minus p mu into ps minus pb. Now phi, that is basically relative humidity, so that equal to, you can write here mu into phi is equal to mu into divided by this term in the denominator, 1 minus p into ps minus pb. This is very important for your semester, for your any in your psychometric relationship, so this is very important, so mind it and go through it in your study. Okay, now so this is the today's class actually. Now in the next class we already discussed on the various relationship, other relationship in psychometric, but one question to you, that for you actually, that if relative humidity basically 100%, if relative humidity is 100%, that means WBT greater than WBT, DBT greater than WBT, or DBT less is equal to WBT. Which one is right? If relative humidity is 100% present, then WBT less than WBT, DBT less than WBT, DBT greater than WBT, or DBT is equal to WBT. Which one is right? Relative humidity means amount of water vapor basically present, that is maximum, right? If the amount of water vapor is present maximum, that is mean if it is 100%, so that will be dry bulb temperature, means the temperature of ambient air, right? So WBT means wet bulb temperatures, mass of water vapor are present. Okay, now if the water vapor present are increased, so obviously so moisture are present, so the actually the temperature is content. Suppose in a thermometer, suppose this is your thermometer. Okay, suppose this is a thermometer, this is a dry bulb temperature, it's a bulb. Now if the water is passing through this, if the already it's wrapped with some moisture or some wet cotton, and if the air is passed through this air, so there is no temperature, so if the air is passing through this, so there is no moisture or air already absorbed, because air is already humidified, so obviously the temperature that basically that indicates basically that is not because dry bulb temperature is very much high, but in case of WBT is very much low, so that will be in first conditions. Okay, thank you very much for listening me and watching me, and goodbye.